Okay, I want to talk a little bit more about complex numbers, and in particular, I want to talk about putting complex numbers into polar form because it is often the best way to represent complex numbers for doing calculations, especially calculations that involve doing multiplication and division. Okay, so let me remind you of how we represent complex numbers. Okay, here we have our Cartesian axes, and I'm going to write this as uh, the axes are represented in terms of real part and imaginary part, as shown right here. Okay, and we said the complex number can also be represented as a vector, and we'll represent that vector um, in this fashion, where we say, okay, the projection down on the horizontal axis will be our x value. And then over here, the projection onto the imaginary axis is IY. So our complex number here, Z, is actually then written in the form Z is equal to X plus IY. Now the complex number can also be written in a polar form in the following way, where we have, say, this suppose the angle made here with the red line and the horizontal axis is theta, and the length of that line is r. We can say that the x coordinate, okay, is equal to r cosine theta, and the y coordinate is equal to r sine theta. And then we can write z is equal to the complex number, as it can be written as r cosine theta plus, let me fix that here, r cosine theta plus I times r sine theta, like that. Now, here's something that you probably have not seen before, and that's a way of writing this expression right here, this r cosine theta plus I times r sine theta. And we're going to use this particular notation. Now, this is a important and useful way of writing this expression. And here is the important and useful part, and that we're going to use the fact that this, we take the number e to the I theta, so e raised to the I theta power is equal to cosine theta plus I sine theta. Now the number e is an irrational number, e, and it's an extremely important number. Okay, in mathematics, e is important as 1 or 0 or pi or e. Remember, pi is an irrational number, and e is also an irrational number, and it has a very particular value. It's irrational, so it can't be written as a fraction, and we e to the I theta is equal to cosine theta plus I sine theta. Okay, now this is important because, okay, this is raising e to some power, okay, just like e squared is equal to e times e, right? E times e. So this is using I theta as the exponent. And if using this particular notation now, we can take our number z, our complex number, and we can write it as z is equal to r times e to the I theta, where r is the length of this line right here, okay, this line, and theta is this angle. Now, what is important about using this notation is that we have the following property, and this property is that, let me take this out here. This property is that if we're multiplying two complex numbers, say z1 times z2, okay, which we can write as x1 plus I1, IY1, x1 plus IY1 times x2 times IY2. We can use this particular notation, which we know multiplying the complex number out can be a cumbersome operation. So we can multiply it this way, or we can multiply it this way. We can take R1 times e to the I theta 1, so the R1 and theta 1 are associated with the Z1 number, times R2 e to the I theta 2, okay, and I forgot the theta 1 over here. And this is written as R1 times R2 times e to the I theta 1 times e to the I theta 2. Now, you should know that if you multiply two exponents like this, that we write this as R1 times R2 times e to the I theta 1 times e to the I theta 2 can be written as e to the I theta 1 plus e to the I plus I theta 2, like that. We just add the exponents when we multiply a number. And let me move this over here. And this further reduces to R1 times R2 e to the I times theta 1 plus theta 2. So this says that when we multiply two complex numbers, that we multiply the radius terms or the modulus terms, and we simply do e to the I and add the angle terms for each number. Okay, now let me show you how division of two complex numbers is also simplified. That if we're dividing two complex numbers, let's say z1 divided by z2, that can be written as r1 times e to the I theta 1 divided by r2 e to the I theta 2. And this can be simplified to look like R1 divided by R2 times e to the I theta 1 minus theta 2. Okay, so this makes multiplying and dividing complex numbers really easy if we use this polar form notation, where instead of writing it in Cartesian form like this, we write z equal to r e to the I theta. The polar form notation is by far the easiest way of writing complex numbers when we're doing multiplication and division. One final thing, how do we compute r and theta from x and y? we do it this way. So let me take this out right here, and we say that r is equal to the square root of x squared plus y squared and theta is equal to the angle whose tangent, so we do the inverse tangent, the angle whose tangent is y divided by x. So we'll do some examples of this representation next time.